Hello. So, unfortunately, last time's problem, which was round 851 problem D, I wasn't able to get accepted. So this time, instead of doing a new problem, I'm going to attempt to debug that and see what is the issue. I'll share screen of the share the question. Yeah, that's my submission. Uh, yeah, and the question is this. Okay. So this was the question. This is my submission. It doesn't work. I get a wrong answer on test 5. Um, I am also looking at how do I see? Okay, click here to see test details. Okay. So here, I know I got a wrong answer. Unfortunately, it's not some nice test case. It's one of these giant 3000 input test cases with definitely like the answer gives me nothing because there's more involved. Um, so yeah, that wasn't, I tried for a bit without looking at the answer, but even after looking at the answer, I don't have anything. So I will attempt to, as much as possible, systematically debug this. So here are the steps what I'm going to attempt to use. So first I'll go over the question, like with a fresh mind. State what I want to do, like ensure it makes sense to me, but like not, I'm assuming right now my logic is correct, but I did made some mistake implementing. I'm assuming that for now. And then I'll go over code and see if I'm just doing, if there's some issue with types, loops, mod, and come up with some edge cases. And then if all that still doesn't yield anything, I'll check the logic itself and think about explicitly try to think about, okay, when can such a thing not work? And any part that I think I'm sure of, but I'm taking for granted, but shouldn't be taking for granted, I guess. So yeah, that's what I will attempt to do. This was nothing. Okay, so the step 1 of this is go over the problem. We're playing a game with n dots on a number line. Okay. The initial coordinate of the ith dot is xi, right? And I have decided to use one-based indexing. So I have like x1 to xn, right? And these are the coordinates. The coordinates can take values 1 to 10 to the 9, right? That fits an int, but because for later we need long I've just used long for these so I had a vector x long for this. These coordinates are distinct. Okay. Every dot starts moving simultaneously with the same constant speed. Okay. Each dot moves in the direction of the closest dot, different from itself until it meets another dot. In case of a tie, it goes left. Two dots meet if they are in the same coordinate. After that, they stop moving. After enough time, every dot stops moving. The result is the number of coordinates where the dots stop. Compute for every subset. So my claim was for like a single set of dots. happening? Is this glitching? Okay. Yeah, my claim was I can do lines now. Oh no, that's command 6. Yeah. If you have like a set of coordinates, if you have the solution for this, it's easy to find the solution when you add this one thing. If you have the solution for this, then you can find the solution for this one thing. So the idea was, if you have a solution for any subset, sorry. Oh, this is, oh, okay, fine. Forget subset. Like I was saying, okay, suppose you have the solution for this set of points. If you add a new point, do you know what the solution is? If you add a new point to the right, what can happen? The distances, was I mistaken in thinking what can happen? My claim was the number of like the solutions, the number of distinct groups either stays the same or increases by 1. Same or increases. I guess I'm doing this first, but this makes sense because I have a fresh look now. It's okay to go over the solution. So does it stay the same or it stays the same or increases by 1? Can I think of a situation where it decreases to begin with? It cannot decrease is the claim because say for instance there were more than 2 groups, right? So to begin with, the guy going right here is definitely not affected. So all of those groups will, whatever groups were there, they'll continue being there. Because yeah, the guy going right is not affected, right, by this point. So therefore, this set can either join with the new dot or could like split up to make 2, which is fair. And the way it splits up is this ends up going right. This closest dot ends up going right, and this one ends up going left. Right. And when does this end up going right? Ah, I see. I guess I missed the case where I mean, later I saw the editorial as well. So I, hmm, I assumed the moment this guy goes right, you will get a new set, but that need not really be necessary. You could end up getting the same number. So I made a mistake in logic. Okay. That was so okay. To sort of state clearly what I realized is um what I had assumed was that if this was my assumption, um and I guess this is related to like the mistake I made initially, which later saw the saw the editorial for, and realized that maybe how I thought a new set is formed itself is wrong, right? Mm, I think it can be fixed. Okay. So the assumption was that if this there's some subset of points here and there's another point here, um, right? So if this goes right, splits into two. But the sort of contradiction, I guess, for that is you can assume like a set of points where um, you can imagine this is at say 5, this is 10, this is 14, this is 17, and the new point comes at 19. Okay, so these guys were all a group, and the way they were a group is, and this was like some, oh okay, 5 is too small. Ah, and there's no negative coordinates. Why did I pick like the, okay, let's start here. 10, right? And this one, and there were like points 1, 2 right here, right? So in this case, 1 goes here, this is fine. 10 clearly goes to 14, 14 goes to 17, and they were forming a new group. And when the new point got added, 17 goes to 19, and you didn't get an extra one. So I was double counting like a lot, I guess. So okay, what after realizing this, what could be like a fix? Fix, realizing that I've done this. So would it be right to say for all the subsets ending here, maybe my way doesn't work at all. Because what I'd said is for all subsets ending here, right, when I add this new point, just look at the guys for which this is closer to this than this. But I don't know. I don't think I can fix my current code. Let's see. Suppose if so you need, okay, then which subsets am I adding? Can I? Wait, my solution? Was my solution? What was the complexity of my solution again? Oh, right. Okay. For each point I looked. Okay. So it is n square log n. My solution, huh? Um, okay. So I guess keeping this in mind, for if you know the solution for everything, like all points up to here, I mean all subsets. Forget even, okay, not even subsets. If you know the solution for this full, like for this, all of these points, and then you add a new point, how are you supposed to find um, whether the solution is +1 or whether the solution's the same? There will be one set here. I mean, that's definitely right. This has to go this side. Um, these don't change. Okay, let's say that these guys over here. I see. Okay. I think I can claim that okay. So previously this was going this side, that's for sure. And every other guy is going to exactly where they were going to go. Like if this was going here, this will continue going here. Um, this was going wherever. They'll continue going. So if it was like this, I think, and this is switching like this, then you have a new um, set. Okay, can I formalize that? Hmm. So if, okay, two things need to happen. The first thing is this is now closer than this. And the second thing is um, this was going this side. Okay. And why I claim that is the following. Um, if this was going this side, this doesn't change anything. But like, can it be some other random guy? Say this is going this side, this is going this side, this is going this side. No. In the beginning, this is obviously going this side. This either going like this or like this. These, this is whatever. Yeah, I think they said this in the editorial. Whenever 2 points are going in the opposite directions, that's when like a new group starts off. I don't know if I can try to fix or if I should just restart. So taking that like logic, whenever 2 points are going in so a new group happens whenever 2 points are going in opposite directions, right? And um, so that is when one is going left and the other is going right. Like not any opposite direction. When one is going left and the other is going right, that's when a new group happens. So if you just take 2 points, if the first is going and like the default is one, so right, left, so nothing. If you take say 4 points, say this is going, so this is going left and this is going right. So then it's starting a new thing. They'll never meet. Right? In all other cases, they'll be part of the same. Okay, that's fair, and that's what let me check that. That is what the editorial was saying. I don't know if this really counts as debugging, like taking way too much help. That's okay. Oh, they can say they're saying the opposite. Leftmost dot. Number of adjacent dots where each mover move towards each other is the answer. I wonder if they're equivalent. Is that okay? So now the question is count dots moving away plus one or count dots moving towards. Are these two equal? I think so. Let's see. Suppose you have blah 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 a set of dots towards 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 towards. Then these guys will be moving away and these guys will be moving away. Yeah, so I guess you can say dots moving away plus one or dots moving towards. I'd say both of them are equal. Okay, let's take dots moving away plus one idea. So again, if you know solutions up to here and a new guy comes, The question is there an extra dot moving away? This moves towards this clearly, right? And now we have two options. I mean, in the beginning, this was moving. So either blah, 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 blah. This move was moving towards this. Either this moves towards this, or this moved this way. If it was like this, and we are counting like dots moving away, right? So between this, nothing changes. Between this, when you do this, nothing changes. You don't have an extra dot moving away. But here, given this moves here, if this goes here, oh, sorry, I should be saying between this, it was never, like this would never, this was always this. So between this, nothing changes because whatever direction, like this is here or here, like, towards or away doesn't change. Between these two, what am I counting? What I'm counting is number of these instances. And I have 4 possible instances. So what happens here, it just goes from this to this. Both of them are cases that we don't count, right? But in this case, it becomes this to this, which we do count and which we don't count. I see. Yeah. So I think it's fair to say first, this is true that this moves towards this, but I also want to store probably a super complicated solution. Okay, let's try for a bit and see. Yeah. But for each, I sort of what do I want to know? I'm confused. So when a new guy comes, I obviously want to know if the subsets, I mean, I want to search among, okay, maybe I'd say condition one, um, that like new distance is lesser than old distance. But also I want to check condition two, that among these, I want to check condition two, which is this guy goes here. So I'm all blank. Oh, I think I haven't been sharing my screen. Oh no. I wish this was automatic. This is annoying. I don't know how long how long I was talking without, because I did quite a bit after looking at the editorial. Okay. So I guess let me just repeat. We said that I was overcounting. Okay, no. First we said like counting dots moving away plus one is the same as counting dots towards. That I like sort of feel that's the case. Okay, let's believe that. Then we said, okay, when you have solution for like n dots and you add a new dot, what are the two cases, right? The first case is this dot obviously moves here, so that's a given in both cases. This is a given in both cases. Now you can either have this dot moving here or this dot moving away. If this moved this way, in other words, if this distance is less than this distance, then you won't have an extra set, right? But if this distance is greater than this distance, you'll have an extra set. So you want subsets for which okay, maybe I can just make okay, it's quite clear actually. If this is A, B, C, I want A less than B because this has to go here. But I want C less than equal to B because this has to. So I need to binary search this condition. How do I do that? What I did now was I had this new point and I was checking for this point. I was like, okay, this point, all the guys for which this is closer. Now for all those guys, I need to binary search or text over. And here clearly it's not less than equal to A is less than B for it to move to the right. But C is less than equal to B for it to move to the left. Hmm. Hmm. So it feels like For each the new point A, I'm looking, instead of looking at each point, a new point A comes in, instead of looking at each point, I'm looking at every pair of points, right? And checking first of all for that pair if this A is less than B. And if that is the case, for this B point, adding up all subsets where C is less than equal to B. But so what does it mean for C less than equal to B? I guess it means look for the smallest or leftmost nay. Then you have to add all of these up. It's not the same as like subsets ending in here are allowed, subsets ending in here are allowed, here are allowed, here are allowed, but here onwards, like starting here onwards are not allowed because this would move to the right. So even if you look at pairs of points that this final condition, like if you binary search this as well, even if you did that, you'd have to add from here to here, or like, okay, that means keep another array to store cumulative sum here to here. It's like a lot. Yeah, it seems like this is a bad idea so far. Let's maybe hold this idea. At least the mistake was clear, I guess. But yeah, if I were to implement this, this would be n times every pair of points, but I don't know if yeah, okay, worst case, like every pair of points and square times, assuming we keep cumulative sum log n cube log n. is the best I can think of. Maybe you can do more story. Maybe I need more brain space. Okay. So yeah, I will count this as having been debugged in the sense that it was too full of bugs, so I will just read the editorial and implement what they have to say. So let's see. Okay, fine. So their logic is that um, for a new subset to happen, you have like these two moving together, right? So when we need to, okay, so I guess maybe a nice way to say this is and I've seen this people do or like change like the order of counting and it works. So I guess what they're basically saying is what we might say is subset one, like one moves, say 1 and 2 move towards each other, 7 and 8 move towards each other, and 12 and 13 move towards each other. Subset two, um, this moves and something else moves. Subset three, this moves. So our way will be like C subset one, how many moves? C subset two, how many moves? C subset. Instead of that, we could do like 1 to 2, how many subsets does this happen? 7 to 8, how many subsets does this happen? And 12 to 13, how many? So basically, instead of counting this way, we count like this to some extent, I guess. And this works lots of the times, I think. So yeah, their idea is so we will iterate over all pairs of points I less than j, right? We'll find all subsets in which these two will move towards each other. And in which subsets does this happen? This happens when, let this distance be d. This happens in all of the subsets on this side with coordinates with coordinate like where, okay, sure, let me say this properly. So with all the subsets that end at any point here, all possible subsets up to here, right? Where this point is such that let's call it k, x of k is lesser than or equal to x of I plus d. and we have subsets up to k, right? I think we need to be careful about a couple edge cases. And here we have L subsets up to L from the right, such that x of L has to be greater than x of j plus d, right? Notice the less than equal to and greater than. Okay. Then other edge cases we need to worry about, like no, literally we're actually counting subsets, like where we don't need to worry about, like, we even like the zero subset, everything counts because there's already 2 points here, right? Like, so this could have 0 points. This could have just 1 point, that's also allowed. So all basically the number of subsets, yeah. Right. And this up to L, I guess, can be total minus up to L minus 1, right? Cumulative sum, and then for this cumulative sum, is this correct? Yeah, that seems fine. Okay. All right. What do we need? Okay, so now I think it's reasonable to just try implementing, or should I? Did I do that again? Oh no, I did that again. Need to remember. Yeah, I feel okay. The goal is to attempt to get an accept before time up. So what do I need here? I need suppose there's 2 points. Ah, there's always one subset, so that's fine. Hmm. So I'm thinking I have for each ij, I add the subsets lesser and the subsets greater. I'm sorry, multiply subsets lesser and subsets greater. And to find lesser, I believe, I mean, I know how to binary search, but apparently there's a sweeping method that you can do in O of n square. Okay, let me attempt the binary search method. Um, I would have binary searched for such a point. If it exists, return that, else return 1. Again, binary search for such a point. If it exists, return of that, I'll return -1. I'll just send the num subsets array also to the. So I'll have one subsets array, one ans array, then there's x, 2 binary searches, one for the largest k less than equal to x of I plus d, and for the next one for the smallest L that is greater than x of j plus d, or smallest L that is not less than equal to okay, right, like both. That looks reasonable. Anything else? Yeah, I have no idea what the sweeping method is. Maybe I will, once I write down my solution, I'll look over other solutions. Do I want to check rough run for the test cases, or do I believe this? Maybe we, okay, now I remember to go to Chrome. Let me rough run on the test cases. One, okay. So 1, 2, 4, 6. So 1 and 2, you need them to go towards each other. So that is, oh yeah, this is just binary. This is just 2 to the power, whatever. But we can actually take powers the ugly way and store them instead of doing binary exponentiation. Instead of repeated squaring, yeah. So you can, so I'll just take an array and happily store, it's just powers of 2. Yeah. So I don't really need like a subset. It's just like I can just call it power or something. It's the power array. Okay, anyway. So for 1 and 2, I just need to check this side it's 1 into this has to be greater than 1. So I see 2. So that's 2 square, that is 4. 1 and 4, that's 3. This has to be greater than 3, that's not. Well, 1 and 6. 2 and 4. 2, this has to be greater. Oh yeah, which side has to be? Yeah, this side has to be greater than 2, and this side has to be greater than equal to 2. So you have 1 into 2, right? 2. 2 and 6. Again, this side has to be greater than 4, and this side has to be whatever, there's nothing on this side. And then 4 and 6 is my last. Nothing on this side, and this side has to be greater than 2, so that's 1. Let's see, 6 plus 4, that doesn't look right. Must have made a mistake. Alright, okay. Start again, 1 and 2. This is 1 times distance is 1. That's fine. 1 and 4. Distance is 3. That's 1 into, this side has to be greater than 3. 1. 1 and 6. 1 into 1 equals 1. 2 and 4. The distance is 2. This side, you'll need something that's greater. This distance will be greater than equal to 2, which I have nothing. This side, I need it to be greater than equal to 2, which I have. So, 2 and 6. 4. This side, I need it to be nothing, so that's just 1 possible subset, and this side I need to be greater than equal to 4. 1, 4 and 6. 2. This side I need to be greater than, this side is 1. This side I need to be greater. Might have, yeah. I think I got this wrong. But yeah, that's the idea. We want 4 to move to 6, so this has to be greater. So that's 2 into 1 equals 2, right? 4 plus 1, 5, plus 6, 11. We're happy. Let me write the conditions. I mean, case such that yeah, I think these are the conditions. Okay, now we will code them up. My ugly old code. Will you share? You see my terminal. Put this here. Okay, there's no test cases. So int n, int t equals 1. Then int n cnn vector llx of n plus 1. Let's take in the input for int I equals 1. Really need to improve type. I less than n plus 1. I plus plus c in x of I. Okay. Let's create the power array vector ll pow of n so on pow of 0 equals 1 pow I equals 1 I less than n plus 1 I plus plus pow of I equals 2 times pow I minus 1 mod. Okay, so this contains all powers. We're happy. Okay, now for the main stuff for int I equals, okay, ll ons equals 0 and I equals 1 and plus 1 I plus for int j equals I plus 1 j less than n so 1 j plus ij ons is equal to ons plus they say d equals x of j minus x of I plus what did we need? Largest k of something. I'll come back and fill that. Smallest L of something. Why am I using Vim if I'm not? Largest k times smallest L mod right. So what do I need to send to this? I need to be sending the vector x of I minus d and the vector and smallest L I'm sending the vector x of j plus d and pow. Okay. Let's deal with largest k. LL largest k of vector LL. I forget how you send vectors by reference. I think it's and. I think I did it in my previous. Yeah, it's and. Okay. Yeah, I don't understand that part properly. LL distance and vector LL and pow. Right. Oh, okay. Maybe let me not call this distance. This is upper bound. Okay, now I need to write a binary search. So I want largest k such that k is less than x of k is less than some value. Um, so the condition is this is less than, and I want the largest. So yes. So the largest yes for a condition. What do you do when you say largest yes for a condition? Yes, we need mid to be here so that if it's no, okay, largest yes as in find a yes, it's in there. So start is equal to mid, end is equal to mid minus one, and we need mid to be start plus end plus 1/2. Okay, that makes sense. Start. Okay, sorry. Why am I using LL for indices? Int start equals 0. End equals. Yeah, I could literally use the whole size because I have my upper bound. Even though this is like lame, but it's fine. Int start equals 0, end is equal to x dot size minus 1. Made. Okay. While start not equal to end, mid equals start plus end plus 1/2. Right? If x of mid satisfies the condition, that means it's less than upper bound, then it's a possibility. So I just say start equals mid, else end equals mid minus 1. Okay, awesome. Then I check if x of start still satisfies the condition, and if it does, return pow of start, else return 1. All right, I think I'm happy with that. Okay, in smallest L vector, because if nobody satisfies the condition, the condition has to be less than. We are clear on why. Okay. Smallest LL, smallest L vector LL, and X LL lower bound L and oh, again in start equals 0. Really need to learn typing in comma and equals x dot size minus 1 mid, yeah, while start not equal to end. Okay, now I need to think. What do I want? I have or I need the smallest L that satisfies a given condition. So it's of the form no, 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 yes, yes, yes. So if I have a no, yes, if this mid has to go to the beginning so that if it's a no, it jumps here, right? Mid equals start plus n by 2 if x of mid is greater than equal to lower bound. And the reason we have greater than equal to is, okay, so greater than equal, it still jumps to the left, right? So if this happens, and equals mid, right? L start is equal to mid plus 1. Because if that's not the case, okay, this seems okay. If x of start is, I looked up like how to do binary search yesterday. Like, I mean, I revised how to do binary search yesterday, by the way. I wouldn't have come up with all of these conditions otherwise, just saying. Like, and to remember when to do the start plus end plus 1 and start plus end. And I might have still not remembered correctly, but I hope that's not the case. Then I return pow off, but I have to be careful. And right, so suppose I have 10 and this is 7. So I need I never sent n. I mean, I could compute it, but I just want to send pow of n. If you're at 7th, n minus n plus 1 is my claim. Else return 1. Looks okay to me. And like the reason I did n minus n plus 1 is, oh shit, what n minus n? Oh yeah, start is equal to n, that's fine. But let's keep the same terminology. Okay, time for, okay, you only see half my screen. So I need to do a new share. I will share desktop one. Share, yeah, okay. for the moment of truth. Oof. Oh yeah, okay. This I can deal with. This is LB, right? Not bad. Now we'll see how bad. The first test case 4, 1, 2, 4, 6. Oi, I don't return. Genius. Absolute genius. Okay, that took care of that. Layout. Fonts and 1, 2, 4, 6. Okay. Dot out 5, 1, 3, 5, 15. Okay, these two are fine. I'm sharing my Chrome screen. Oh, submit. Oh, yes. Yes. Okay. That's nice. Certainly feels good. Yeah, that was fun. In case you guys want to look at the code, I will link it. But one thing I did want to do was look at some random code for a bit. Let's just look at this first person's code. And yeah, one thing they did I noticed is they just have this whole modular arithmetic thing. They're not worried about the mod part. I feel like, yeah, they have this struct for, I think it's modular int, or I don't know what is the emint for. So yeah, that's something I could do. Okay, they also did the whole power thing. They didn't like do repeated squaring. Wait, there's no binary search. There's no comical. Is this like the sweeping thing? Oh, yeah, I'm sharing the right screen. They didn't like break their heads over the binary search cases. So while L greater than equal to 0, x of I minus x of L less than equal. What is this even? Okay, let me think for a second. tastes good after getting it accepted. That's just water. So, okay, what's going on? What is L and R? L is equal to I, R is equal to I. Okay, I'm assuming they stand for left and right. Greater than equal to 0. I see. That is quite smart. Okay, I think what is going on here is um you share. Okay. So okay, what I had done was Once I had an L and an R, I knew that I need some guy less than this distance and some guy greater than this distance. So I just like binary searched here, right? And I binary searched here. But what Jiangli did was, so okay, no, they call this ing. Let's call this ing. Um, they we know, okay, so we know the way we are moving this ing around is we are starting with I here. Okay, we're keeping I, say, fixed at some place and constantly incrementing j, right? That's what we're doing. Okay. So this, if for a given I, we find that this is the value of L, as j increases, we know it can only go this way. It can only decrease. Similarly, for a fixed I, as j goes this way, like for a given j, like say the r values here, as j increases, r can only increase. So what happens is you can keep incrementing till you find the, value on this side and then keep incrementing on the other side. And the reason this turns out to be O of n square and not, O of n, I guess, is um, for every, how do I think about the complexity of this? G for Yeah, I guess the way to think about it is for each I, the L's are independently going to the left, right? So for each I, the L incrementation does like I work, at most I work. So you can assume, say, N work. And independent of that, um, this INJ business is going on. And then again, so it's more like the way I would look at it is N times N plus N plus N, right? So this is, sorry, incrementing, decrementing L incrementing R, incrementing J, right? So that's why it's O of n square. Because like these happen separately, which is pretty cool, and the code is like so much better. Yeah, I think I did come. I mean, I don't remember. It's been some time, but I guess that's why I understood it quickly because I saw it before. So that's nice. Yep, I will stop there. I won't code this. Ideally, I should code this though. To see I ensure to ensure I get it. Okay. Let us power through. Should I or should I not? No, I should probably code this tomorrow. Because right now I might just like I might spit out what I just saw in there. So I'm just going to write this idea down and code it tomorrow. Okay, so that's it. See ya.